Okay, today's lesson is to write an equation in slope-intercept form. Do you remember what slope-intercept form is? Slope-intercept form is y equals mx plus b. And remember, m is the slope of a line, and b is the y-intercept, where the line crosses the y-axis. So today we're going to be looking at how to take different equations and to use algebra skills to solve for y, to get y by itself, to get it into slope-intercept form. So here is the first problem. So here's our first problem. So sometimes kids like to write a little line so they can see the left-hand side from the right-hand side. And notice that we have x's and y's on the left-hand side. And we want to get the y to be by itself, because we want to get it in slope-intercept form, which means we want y to be by itself. So we have to remove the negative 6x's by adding a positive 6x, and whatever you do to one side, you must do to the other. So a negative 6x and a positive 6x is 0 x's, and that leaves us y all by itself on the left-hand side. Now, these two terms are not like each other, because one term has an x and the other term does not have an x. So these are not like terms. So you cannot combine them. So all you can say is that you got a 6x and a positive 7 on this side. Do you see that we have y equals mx plus b? Do you see how it looks like that? And couldn't we say the slope is 6 and where it crosses the y-axis is 7? And this is called slope-intercept form. Slope-intercept form. So we used our algebra skill to get y by itself. So let's try a few more problems. Here is problem number 2. Again, our goal is to get y by itself and get the x's and the constant term on the other side. So that's what we're trying to accomplish. So I need to remove the negative 4x by adding 4x's, and whatever you do to one side, you have to do the other. So a negative 4x and a positive 4x zeroes out the x's, and we have a negative y equals, and then these two terms are not like each other because one term has an x and the other term does not have an x. So I have a 3 plus I have a 4x. And that's an okay right there, but notice how the x's are first and then the constants last. So we often prefer to put the x's first. Technically, it doesn't matter, and then the constant term last. But we still haven't gotten y by itself. We want it to just be y. So remember, this is like a negative 1 is being multiplied. So then we're going to divide out the negative 1 to every single term. And when you do that, you get y equals, and isn't 4 divided by negative 1? Negative 4x's. And isn't a positive 3 divided by a negative 1? A negative 3, so we're going to say minus 3. So there is your equation, and y equals mx plus b, which we call slope-intercept form. Because isn't the slope negative 4? And isn't where it crosses the y-axis negative 3? Let's try another one. In this example, we already have, the x's are already on the other side. So all we have to do is undo dividing by 3 by multiplying by 3. And when you multiply or divide, you do it to every single term. So we have to multiply each of these by 3. So remember, that's just a fancy way, right? That's just a fancy way of saying that I'm going to multiply this by 3 and I'm going to multiply this one by 3. So instead of writing that, we just say we're multiplying both of these by 3. Usually kind of like to squeeze it in the front, but you can always put it in the back, right? So don't we put a 1 underneath that? When you multiply, can't you cancel And doesn't that leave you just y equals? And then don't we multiply 3 times 2x, which is 6x? And don't we multiply 3 times positive 1, which is positive 3? So remember, that's the distributive property. We're multiplying 3 to both of those things inside, and now we've got it in slope-intercept form. Let's try another one. This one is a little bit longer. So if you notice, on the left-hand side, we actually have 3 terms. And remember, we're trying to get y to be by itself. So we want to remove the subtract 5 by adding 5 to both sides. A negative 5 and a positive 5 is 0, so that just leaves me 4x plus y divided by 2 equals, and negative 10 plus 5 is negative 5. So we can combine these. These are like terms because they're both numbers without variables, and those are called constant terms. So these are like terms. So we can actually add them together. And negative 10 plus 5 is negative 5. So now we want to remove the x's by subtracting 4 x's. And whatever we do to one side, we do to the other. A positive 4x and a negative 4x zero out the x's and leaves me with just y divided by 2. And these are not like each other because one term has a variable and the other term does not have a variable, right? One term has an x and the other term does not. So those are not like terms. So we cannot say negative 9x. That is not allowed because they're not like each other. So that means we have on the right-hand side, we have a negative 4x and we have a minus 5. Remember, our goal is to get y to be by itself. So we have to undo dividing by 2 by multiplying by 2. So we have to multiply both of these by 2. Now, I kind of don't have room to squish it in there, so I'm just going to put the 2 back there. So that gives me, I'm going to multiply 2 to both of these. So when I multiply 2 times 4x, I get negative 8x. And when I multiply 2 times negative 5, I get negative 10. See, I have y by itself, and this is called slope-intercept form. And we love slope-intercept form because we can identify that the slope is negative 8 of the line, and we can identify that the y-intercept, also known as the b, is negative 10. So if we wanted to graph it, we could use that information to graph. Let's see, let's do maybe one more. So once again, we want to get y by itself. So we have to remove the x's. So since it's a positive 8x, we want to take away 8x's. Don't forget to put the x, right? You're taking away x's, so don't forget to write the x. Positive 8x and a negative 8x zeroes out the x's. Don't forget you have a negative in front of the two y's. This term does not have an x, and this term does have an x. So they both do not have x's, so they are not like terms. So you cannot add those together, right? So on the left-hand side, we've got negative 8x's. We like to write our x's first, and then we have a positive 14. Remember, we're trying to get the coefficient to be just one y. So we undo multiplying by negative 2. Remember, this means negative 2 times y. So we're going to undo multiplication by dividing by negative 2. And whenever you multiply or divide, you must do it to every single term. And isn't negative 2 divided by negative 2? Doesn't that give you 1y? And 1 times y is just y. And then negative 8 divided by negative 2 Isn't that a positive 4? Don't forget your x's. And then a positive 14 divided by a negative 2. Isn't that a negative or a minus 7? Now we have it in y form. And that is called slope-intercept form. What if, when you're doing a problem, what if I have something like this? Like negative 3 plus 4y, whoops, negative 3x's, or let's put the y's this way. If I have 4y minus 3x's equals negative 12, don't I need to, right? Don't I need to remove the x's? So if I have a minus 3x, don't I have to add 3x? Whatever I do to one side, I do the other. Doesn't that zero out and leave me the 4y's on one side? These are not like terms because one term has an x and the other term does not. So I have 3x and I have a minus 12. And then I'm going to, since I'm multiplying by 4, I'm going to divide out the 4. And if you're multiplying or dividing, you must divide to every term. That gives me y equals. And 3 divided by 4 is not divisible, not dividable, right? So it's just the fraction, 3/4. Don't forget if the fraction can be reduced, you should reduce, which it can't be. And then isn't negative 12 divided by 4 negative 3? So if it's not if you can't divide it, that means your answer is just a fractional answer. And if it can be reduced, you should reduce. Okay, I hope this helps you writing equations in slope-intercept form.